Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.
I'm going to do some stuff on the theory of equations, and these equations will actually be just polynomial equations, so there'll be no trig functions or exponential functions or anything of the kind involved here. And we won't bother with the linear equation, that's fairly trivial. We'll go straight on to the quadratic equation, in which the highest power term is 2, an ax squared. So that's the general form of the quadratic equation. Ax squared plus bx plus c is 0. And without loss of generality, this can be rewritten as x squared plus bx plus q equals 0. And we'll say that its roots are alpha and beta. First thing you want to do is find the equation. An equation whose roots are the reciprocals of those, 1 upon alpha and 1 upon beta. In other words, the new variable, which we'll call y, is equal to 1 over x, or what is the same thing, x equals 1 over y. So what we need to do then is substitute for x in this equation here, replacing x by 1 over y. So that then becomes 1 over y squared plus p over y plus q is 0, and then multiplying up by y squared, we get 1 plus py plus qy squared equals 0, and that does for that little bit. And now move on to find an equation whose roots are k greater than the original roots. K could be some number, 2, 3, 4, minus 3, minus 6, minus 7.5, anything like that. So the next thing we want to do, find an equation. I've just changed the color. Find an equation whose roots are alpha plus k and beta plus k. Say k can be a positive or a negative number, makes no difference. So in other words, what we got this time, we got y is equal to x plus k. In other words, x is equal to y minus k. And we do as we did before, we substitute for x in the original equation here. So what do we get? When we substitute, we get y minus k squared plus p into y minus k plus q equals 0. There's your new equation. We got rid of the x's completely, and there are no radicals in there. You can leave it like that, but if you want to tidy it up and get it back to the general form, just simply square that out. So that's y squared minus 2ky plus k squared plus py minus pk plus q is 0, and then collect similar terms. So you got y squared. The y's are there and there, so that's plus p minus 2k times y, and then the constant terms, which are k squared minus or plus q minus pk equals 0, and that finishes that little section. Let's make sure that that is right. Yes, that looks fine to me. So we can move on to the next stage, and that is to find an equation whose roots are multiples of these. Okay, so to find an equation, let's change the color again. Find an equation with roots, we call that h alpha and h beta. Again, h can be any number, positive, negative, fractional, or otherwise. Okay, so this time y is equal to h times x. In other words, x is equal to y divided by h. And now substitute back into our original equation here. So we get this one here, y over h squared plus p into y over h plus q equals 0. Let me make sure I've got that down correctly. Y over h squared. Yep, that seems to be okay so far. And then simply simplify all that. So you've got y squared over h squared plus py over h plus q is 0. We want to tidy that a little bit, just multiply through by h squared, and we'll get y squared plus hp y plus h squared q is equal to 0. Let's make sure that that is right. That looks fine to me. Okay. Our next stage then will be to find an equation whose roots are the squares of the original equation. Right. Right, we now continue with these, and we're now going to form an equation whose roots, find an equation with roots alpha squared and beta squared. But first of all, I'll do it my way. Touch of the Frank Sinatra's coming on there. Right, okay. And this is what I do. So there's our original equation. X squared plus px plus q is 0. I'm going to rearrange that. So that x squared plus q is equal to minus px. Now here, this let me say that in this particular equation, y is going to have to equal x squared. Okay, so the x squareds are replaced by y. So we can straight away here put on y plus q equals minus px. The next thing to do is to square both sides. We've got y plus q all squared equals p squared x squared. And remember, x squared is y, so that is p squared y. That essentially does it, but we can multiply that out, and I won't go through all the details, it's quite easy for you to do. That'll come down to y squared plus 2q minus p times y plus q squared is 0. That finishes off that little bit. Now, that was my way, but there is an orthodox way of doing that, which I shall now do. And then it's up to you, if ever you get a problem like this, whichever way you want to do it, okay? So the orthodox method is as follows. You write down the first equation as it was, x squared plus bx plus q, and now you write down a second bracket in which x is replaced by minus x. So that would be x squared minus bx plus q equals 0. Okay, we write down this, the orthodox method. Okay, well, let's multiply out. And remember that x squared equals y. So we can rewrite that as y. I have a problem with odd. Y plus px plus q and y minus bx plus q is 0. So let's multiply that out. Y squared minus pxy plus qy. Now we'll multiply each of those terms by the px. So that would be plus pxy minus p squared x squared p squared x squared, and remember x squared is y plus pqx. And then finally, multiply each of those by the q. So that would be qy minus pqx plus q squared. That's equal to 0. Well, let's tidy all that up. Get y squared. These terms drop out. The y term will be 2q minus p squared y. These drop out, and you've got q squared equals 0, which I hope you can see is exactly what we had over here. I prefer this method because it's quicker, no other reason, all right? But if you forget what to do in an exam and you're panicking, you can always fall back on that. It takes a little bit longer, but it gets you there in the end. I have to apologize because I made a slight slip over here. That should be a p squared, as it was there, and not a p.
Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.